So hello everyone, I welcome you all in this lecture. So in this class we will study what do you mean by the tracking controller and what do you mean by the stabilization. So just recall, uh, have you heard this word stabilization and tracking look like both are same, right? When you call it is a stabilization and when you call it is tracking. Okay, something you might have heard that ki, I am tracking the angle value, I am tracking the trajectory value. Okay, and on a other side you are just uh, I mean to say might come across that stabilizing the attitude of a satellite. Okay, so the basic difference is it lies in the fundamental only. Let's say when you are commanding anything, for example, let's say you are commanding any kind of angle. Okay, so simply what you can write, let's say you are commanding roll angle, phi command minus phi, and you multiply by the some gain. You multiply by the some gain and you got some kind of u value. Okay, let's say for example, and that can be the k can this can be p command minus p also roll rate, you will get u, let's say. So basically here you are trying to achieve phi roll angle and you are trying to achieve roll rate. Okay, let's consider the scenario, and in block diagram you will see, let's say you are commanding something. Okay, let's say I am commanding roll rate. Okay, and this is a plus 1 and see this is a minus and you are getting the feedback p from the plant. Okay, and this error is going to the controller. Here I am taking only k proportional controller, you can add d and I also. Okay, and finally it goes to the, it passes through the physical limits and then plant, right? So here basically you are trying to achieve p command, but also I have explained to you, take a feedback and multiply by some gain k. Okay, so feedback into gain is called stabilization. When you are taking feedback and multiplying the gain, that is referred to as a stabilization, and taking the error and multiplying the gain, it's called tracking. Okay, so in many cases you will see taking a feedback and multiplying the gain. I already explained to you in the previous lectures, like let's say you have a aircraft, it has some natural response, right? So how will you find out the natural response? Find out the matrix A. Okay, and then find out the eigenvalue of those matrix. In longitudinal case you will get short period and forward mode. Okay, and let's say if you have a complete aircraft 6 degree of freedom, you can initialize and you can insert the input, you can see how then my aircraft naturally look like. Okay, for example, consider the pitch rate example, for example a roll rate example. So it is start from, let's say like this, it was the natural response case, but when you are taking the feedback and multiplying the gain, how does it become? The response can be like this. So basically by taking a feedback and multiplying the gain, you are, what we are doing, you are artificially damping. Okay, let's say in this case the zeta value, for example in this case the zeta value was 0.2 and in this case the zeta value can be 0.8, just by taking the feed and multiplying the gain. That is called stabilization. Okay, so what will be the block diagram for this? Let's say first you have to take a plant. Okay, here you have some q command or p command. Okay, let's say p command you are having, and this is plus sign, this is minus, obviously. Okay, and this is the error is coming. Okay, and this is error, and basically this you are supplying to the physical limit. Physical limit I explained to you. That means first position limit comes, then rate limits come, then actuator dynamics will come. Okay. Position limit of a, for example, in this case, a roll rate case, the position limit can be a plus minus 30 degree for aileron. Okay. This is aileron control surface that can be plus minus 30 degree, right? And then what can be the rate limit? 10 degree per second. Okay. And actuator dynamics you can model as a first order or second order. Okay. So now here when you command, see, in stabilization you want to damp out the system, right? So that means this should be 0, right? And here you take the feedback and you will multiply by some gain. Okay. So that is called basically stabilization. Here in this roll rate case, what will be this? This is the aileron input. Okay. And when you change from this P to Q, that can be elevator. And when you change from P to R, that can be rudder. Okay. Now let's say in a natural case the root location was this, near to origin. Okay, above the origin also, close to the imaginary axis also. That means you will see some kind of oscillatory response. But here by multiplying this gain only, you may reach to this point or this point or exactly this point where you have a no oscillation. So by taking a feedback, you are moving the root on a root locus in order to get the desired damping. Okay, so that is called stabilization. Okay, and if you are taking a, let's say this is P command, for example, so and you do not take a feedback and multiply by the game, just take a feedback, and here you in error you multiply some gain. So what will be the delta A? Delta A will be equal to K into P command minus P. That is called actually tracking controller. Okay, so do not confuse with the tracking and stabilization. Okay,